We are the Rolling Robots West LA team, and this is our robot. We designed this robot to be modular and versatile so that we could attempt multiple missions. We started with the chassis and built onto it to give us many connection points so that we could attach other parts. We added this big plastic arm to help us with the shipping container off the boat mission. It sticks out just enough so that it moves the crane when we drive by. We added this ram to help us with moving the plane off and the truck off the launcher. It pushes down the lever more efficiently than these bottom wheels do. We also added these forward mounts right here to help us with the helicopter package drop mission. We made them as small as possible so they wouldn't get in the way of the truck and plane mission. Our strategy was initially to do all the easy missions first, but we couldn't perfect the forklift design early enough, so we decided to skip the cargo movement missions due to time. We chose the missions we wanted to do, then planned a route that would reach as many of them as possible. We chose them based on the missions that were closest to the previous mission.
We built this lift to lift objects. The structure is two sets of worm gears because one wasn't coming out. It was just making this axle part spin, but with two it would steady it out so it would go up and down. We also used a lot of beams to hold it upright, and it took a long time to design how you put the motor on so it wouldn't fall off. The missions we were originally going to use this for are the doorstep package, the turbine blue holder, and the hinge container. We may not do those missions because we needed the lift, and we might not have enough time to attach the lift onto the robot. The lift can lift objects by either skewering it in the holes with these axles, going in the middle there's a blank part going through there and then lifting. And also if an object that's put on top of it, it can lift. It can also drop the thing by just driving backwards.
We are using LEGO Education to program our robot. The LEGO Education software has its own measurement system that was not in inches or degrees. That made it hard to map out the robot's course because we didn't know what the measurements meant. So we made our own code to drive in inches and turn in degrees. Once we had the drive and turn blocks, we chained them together to complete different missions. For example, the platoon and truck connecting to the bridge. It was much easier using the drive and turn blocks because instead of putting in random numbers and seeing if they worked, we actually could measure them. And because of that, it took us much less tries to get the measurements right.